to draw a slab street, we need to go to our plan for the second story, because that's where we are drawing a slab strip. So you can just go to your modeling, back to your modeling, then go to strips, and just like I mentioned initially, we'll be drawing analytical strips for this for the main slabs, and for the inclined slabs which have plane definitions, which is the ramp, we'll be drawing a FE strip for them. So we'll go here and we'll be choosing the fixed band strip, which is not checked yet. So let's draw our analytical strips. We've already covered video tutorials on drawing strips and how it works. So when you are drawing your strips, you usually from your left to right, and also from your bottom to top. So for the x-axis from left to right, from the bottom, on the y-axis from bottom to top. So now let's just, and you have to click the direction right here in order to not get the wrong interpretations or the wrong design for your slab strips. And also the boundary conditions are very important. This from slab to slab, bob to bob, cantilever to cantilever. So if you have slab to bob, you indicate it here by clicking it. If you have slab to cantilever, you indicate it here by clicking it. If you have bob to bob, slab to bob to slab. So just like that, So here we have this from bob to bob, which means from the end of the beam to the end of another beam. So we are going to be using this for this. So, and it's going to be pretty much the same for everything that we have here. So let's just draw our slab strips. So you can press your control to just make sure that you are drawing a very straight slab strips. So, and that we have that. So we also draw for this as well, and we hand it somewhere around here, and you go there, then you draw for this too. We hand it somewhere around here. That's where our slabs end. It's also from beam to beam, and this also is also from the end of a beam to the end of another beam. So we have for our x-axis drawn. Then we go to our y direction, and in our y direction we realize that it's also from bob to bob. Everything is from bob to bob, or you could choose from slab to bob for this one as well, depending. So let's draw this right here. So we can draw this right here by pressing your control. Just make sure that you are drawing something, drawing a straight line, and draw a straight line. And you can also always check the information below your slab strip, which says delta x is equal to 0, delta y is equal to 21,700. It helps you to know that your change in delta x, especially when you are drawing in the y direction, has to be 0, and it's 0. So here now we can change the boundary conditions for here, because there's a slab that is actually coming into this slab strips, and go to y direction, just like y direction here. So I'm going to click from slab to bob here, and you have that right here. So, and you can see that it's giving me y-height here, which is not very good. I don't intend to use y-height for my slab. So what I need to do to correct this before I go on to design my fixed band strip is to adjust the settings in both my building analysis and also in my settings, general settings. So I'll go to model, I'll go to pre-analysis, and I go to edit materials, and you see concrete columns. I have C20 to 25 for the grade, which is good. It is what I want to use, because actually this is 1620 depending on what the specifications are. So but I'll leave everything here as default. Then I go to rebar diameters, and I unselect all. For the columns, I want to just use y16, so I'm going to choose y16 right here. For the concrete walls, that's the shear walls and all that, I want to also use y12, so I'll click on the y12 and press OK. For the web bars, I don't have web bars, and it's not really a matter of concerns here, so I can decide to choose 16 for that, and I can also just leave it as it is, because I'm not really using it. I don't really need web bars. So now concrete beams, which is our subject of discussion, the subject of discussion for this project. So we'll be using y16 for our beams. So now we have slabs. So for our slabs, we need y12. It's also a subject of discussion. Actually what brought us here. So we need y12 for our slabs, and then the rib, which is also a slab, it can be our rib slabs. We also use white cloth. Then for the links, we need, since we are using Y16 for our beams and columns, we can just simply choose only Y10 for our links, which is very okay. So you press OK here, then you go, then you close this, then you go back to your building setting, building setout, then you go to your settings again, and you look for your columns. So the rebars for your columns. Let's check everything. So the links is Y10, and you see that it's here, which is registered, which is okay. So and the design, so you have the parameters and you have everything is okay for our columns here, and you can go on to our beams. So the links of our beams as well is also Y10. And what I want to actually touch with this is the diameter of my steel bar. Yeah, so the minimum steel bar for the beam is Y16. So Y16, and maximum is Y16. I don't want it to use anything inside Y16 for my floor beams. So and then then the link also Y10. I don't want it to use anything less than Y10. The angles Y16. So I'm just going to, and the cover here by default is 20 mm. And then you also have all these minimum top rebar spacing 40, which I'm not going to touch anything here for now. I'm just going to leave everything the way it is. So and the minimum support link spacing 300, minimum link spacing 100. So I'm going to just press OK here, but before I press OK, I also want to go to my slab to arrange that too. So I want you see it's writing Y80, which is not very good for me because I want white top. So I'm going to change that to I'm going to change that to white top. And we have maximum spacing as 250, which I'm going to leave, and minimum as 100. So and steel bar spacing 25. So everything looks okay here. The appearance also. So what I want to do, what this does is that realize that it only showed the total length and the span length and everything. There is no number of line designated for our design, but for now I'm going to leave this. I'm going to come back to check it later. So I can press OK, and once I press OK, you see that you still have Y8 at 150 here, which is not very good for me because the design is supposed to be white top at 250. So what I'm going to do here is I'm just going to go here and I'm going to update steel bars. And once I update steel bars, you see that you have white top at 50 right here, which is designed. But we have not already done an analysis here, so we still don't have a concise, perfect analysis for the number of bars that we need. But at least it's just good to use these settings initially, so that by the time you do your building analysis and you design your steel bars, to bring out the values for you without any hassle. So let's draw a big span strip for this. So we go back to modeling, slab strip, then we go to change this to FE strip, then we'll go to FE, then we'll click on fixed band strip. This is fixed band strip. This is span strip, this is rib strip, and this is span band, this is support strip, and this is fixed band strip. So now we need to draw, and we also need to check our direction. So in the hex direction, which is this direction, we need to draw our fixed band strip. And in order to draw a fixed band strip for the X direction, we need to pick our points. We need to pick our point. So what I want is I want the fixed span to cover the entirety of this ramp, even though I could do it sectionally, but I want it to cover the entirety of the ramp, since the ramp is just it's a stair, it's more like a staircase or something. So I'm just going to draw a ramp to cover it. So now let me draw my strip. I can draw my strip somewhere around here. So let me draw the strip somewhere around here, and it's in the X direction. So you make sure that delta Y is 0, and then you can click right there, and you can see that the strip is actually just covering this small portion of the slab, but I want it to extend down here, and I want it to extend up there. So what I'm going to do to achieve that is I'm going to adjust the scope width here. So now you see that this is 1000, so I need to make this, I can just adjust it systematically. So I can change it to 3000 and update. And once I update, you see that it has expanded. So I can make it like, let's say 6,000. I need it to be, and it's already out of the boundary, so I need to bring it down to 5,000 something. So that's 5,000. Let's make it 5,000. Let's 700 and see. I don't want it to fall outside the slab. So let's make it 5,600. So I have, so that's 5,500 or 450. So let's make it 5,450. Yeah, I think I'm okay with this. So now the other side of it, this downside of it, I can make that one. Let's make it 8,000 for starters and see where it takes us. Now I still need it to be more than that. 10,000. So 10,000 is too much. You can make it 9,400. Update. So that's 9,300. So 9,300 falls. I just make it to 50. 9,250. And see where it falls. I don't want it to fall too far away. Yeah. I think 9,250 is okay. It's okay. Or let me just leave it at 9,300. 300. Yeah. So now I have, and I can actually even take this also to 5,000. Let's say 480. So that it's on the line. Yeah. So now we have a fixed band in the X direction. So I want also my fixed band to be in the Y direction. So I'm going to change the direction, and then I'm going to draw another strip, another FE strip. So I can actually make it integral. I could also leave it, to not the integral. So but I can leave it to be maximum, because if it's not integral, it's then maximum. So but I'm going to check integral strips, so that it will be economical, because integral strips help to create economic design, more economic design rather. So now I'm drawing my strip in the Y direction now, and I'm going to make sure that the strip is I have my delta x to be 0, so I'm drawing the strip. I see that the strip is very very wide, and it's because of the parameters we used initially for the first strip in the X direction. So we need to reduce this and reduce it to, let's say, 2,000. Let me reduce this to 2,000 and update it. But 2,000 is way too much, so let me take it to 4,000. So 4,000 is too much, so something within 3,000 then. So 3,000 is still outside. Let's give it 2,800. Yeah. So I think 2,800 is good for us. As you can see, 2,800 is okay. Let's give it 3,000 first and see how it goes. So 3,000 is too much. So 2,000, let's give it 500. Okay, so 500 is not too much. 2,100. So 2,100 for somewhere around here, which means 1,900 should be okay for us. So now we have our fixed band strip drawn now in the X and Y direction, and yeah, I need to update this because I changed to integral strips. Okay, this one is in integral strips. Let me check this. This is also in integral strips. Okay, I need to update it. So now we have our fixed band strip, but one thing about fixed band strip is that it's not going to, or FE strip is that it's not going to bring you a design unless you perform flow analysis, So let's try to, since we have our strips now drawn, you can go to your 3D, even though strips don't show in 3D. So you can now go on to perform a building analysis on this. Since you have drawn this, you can go on to perform a building analysis. I think we can go on to just we have decomposed the load, we have created load cases, so we can perform a building analysis on this. And we've also edited our materials, which is one of those things that are very important. And in order to perform building analysis, you also need to check some other things, like these reduced zones. Now I'm just going to leave it as default, which is reduced by 25%. And I'm going to leave everything here. So we are using user defined support, and user defined supports are actually a pin that you see under your these pins that you see under your structure, your structural members, your columns most effectively, or any load that any structural member that is capable of carrying the load straight down to the foundation, like the walls do. So let's go back to our building analysis and model option. So now let's go to shear wall. Since we are using shear wall, you can use a mid pair, even though it's more advisable to use finite element shell, but because what we are designing is not really very important, I'm just going to leave it as mid pair, because but if it's a very big, if the elements are bigger and the elements are more pronounced and have a detrimental effect on the structure, I'll be going for finite element shell so that it can properly analyze and detail what I'm designing better, in a way that will be more reliable and provide better structural integrity for structure. So now the slab model. Since I have ramped here, I'm just going to click no rigid diaphragm so that I won't run into problems when analyzing my design. And then I'm going to click include slab in building model. Since I'm clicking this no rigid diaphragm floor levels, I have to click include slabs in building model, and I will use undecomposed slab and ridge. Then stories to be mesh, I can just click both, even though I can just click the second story right away. And I could decide to reduce this 800, but I'm going to leave it as default. And in plane membrane for the slab stiffness coefficient, I'll leave it at 0.25. And I can go on to my I'm not using Spark Solver for this building in order to not run into problems while I'm drawing. So I'm going to leave this as I'm going to use you can actually use decomposed beam loads or undecomposed slab loads. When you use decomposed beam loads, means that beam loads will be calculated, as loads that are actually decomposed on the slabs, and you have a very different analytical diagram, bending moment diagram, all that for your structure. Why, if you use undecomposed slab loads, it means that for the story width and gravity calculations, it means that your slab is going to act as an independent structure without the beam loads being decomposed to it. So you can use decomposed beam loads. I don't think it makes much difference in this case, So, and you can now go to analysis, do building model check if there is something wrong with our building model, and there's nothing wrong with our building model. So you can go on to just analyze our building. So we can go on to just do that and hope that we won't run into any trouble. And we have relative storage drift satisfies the limit, relative storage drift satisfies the limit, and on the y-hand x-axis, and we have everything perfect. We can check our Asia load comparison report and see that it has on 1924 as dead loads based on slabs, and when it was decomposed to beams it becomes 1922, and the building analysis report also gives us 1922.6, which is very, very close and less than 5%, and that's why we don't have any problems with our Asia load comparison report. And now you can close this and go to our analytical model. So in the analytical model, you can get the value for the displacement. You can also play the animation to see how it works, and you can see the deflection, and the maximum displacement here is 1.131 for the dead load alone. So what I'm usually always interested in is to get the value for the dead and live load combined, and you have 1.84 also for that, for the dead and live load combined. The dead load itself is what, 1.31. So dead and live load is 1.846, which is very, very okay in my opinion. It's very, very minimal because this is actually in millimeters. I already adjusted my units to millimeters, not meters. So this is very, very small and almost unrecognizable. So I think the building is very, very okay, very, very solid. You can close this analytical model. and go back to your drawing, and now you see that you have this properly and well and properly designed, but you also see that we don't have the value of reinforcement for our finite element strip yet, and we're going to attend to that by doing a FE floor analysis. But before we do that, we want our bars to be properly designed. You can see that this is just Y12 at 250 at bottom 1, Y12 250 bottom 2. We need the numbers of bars that are needed actually. In order to do that, we need to go back to our building setup. What we didn't do the other time is what we're going to do right now. So we go to slab, as you can see the appearance, then we'll go and click on show number of bars, then press OK. And once you press OK, you see that we now have this 19Y12 at 250, 19Y12 at 250, 19Y12 at 250. So we have the number of bars displayed. And now, in order to take care of this this particular issue, because we need the number of bars on our IP strip to also be displayed, so we can go on to our analysis again, then we'll go to IP flow analysis, then we'll go to chase down, because we want the loads to be decomposed on from the highest story to the lowest story. So but in order to continue with this, we need to change the slab stiffness factor to 0.25. so we can do that by just going here, click on this, and then change this to 0.25, because the slab needs to be less stiffer than the columns and the beams. So in order to not have problems with your structure, because your structure needs to be a little bit flexible and not all rigid, for all the members to have good relationship with good interaction and relationship with each other. So now we're going to just click that. So I'm leaving everything here as default. So now I'm running the FE floor chase down analysis, and it's going to start from the highest story and it goes down all the way down to the lowest story, as you can see. And once it's done, it will let me know. So it's telling me that the maximum positive movement is 0.06 and the maximum negative movement is minus. So this is very good for me, nothing to worry about. So I'm not going to go to set FE floor slab. FE slab analysis is completed. So I'll go to floor mesh and analysis, just check what I have here, so I can create the model. So, and I don't really have much to do here. I'm just going to close it. I'm just going to close this, and then it takes me to post analysis, and I go into post analysis to just check my drawing again, and I don't really have much also to do here than to just apply this for the entire floor 1 and floor 2. So I can close this, and then I'll go to include strip in slab result and all that. Then consider pre-torsion effective and hammer in slab, which is always recommended. So I'll press OK, and then I close. Then now I'm going to do, you see that even with that done, you still don't have your slab strips. Let's go to stereo 1. You want this to be stereo 1. Still don't have your design, even when you go to update, because we're going to still update. So let's update this. See that it's not bringing out our design yet, and that's because we need to do the floor analysis for this particular floor separately, and that's what we're going to do now to make sure that so we're going to do a floor analysis for this separately, and once we do a floor analysis for that, see that it's going to generate what we now want. So you can see this is the floor analysis for the second floor where we have our ramp, and this is our ramp right here. So we generate model, and once you generate model, you see that it generates with our slab strip. So, and once you generate model, you can go on to just close this, and we'll go to the analysis. It takes us to the post analysis, and when we go to post analysis, you see that we'll see our slab strips right there, and you see that we have our slab strips here. Now we have this slab strip generated here. So I'm waiting for it to load up, and once it loads up, so, and you can always go through your parameters here, even though I use your standard contours to know what is working and what's not working. So I'm just going to close this right away, because what I'm interested in is I want the my bars to be generated. But let me just check something right here. Let me just check something right here. So let's check something right here. So you can use a standard control scheme, know the value of what is required and what is provided and all that, you know. So but that's not the focus for here, so I can just simply close this and I'll still consider precaution effective and hammer and slab design, and then can also transfer slab strip FA analysis result. So once I do that, it copies the slab strip result and transfers it into my drawing so that I can view it. So now I'm done with this. So you can see what I just need to do now is to click on this and update it. So once I update it, you see that it brings out my design. It brings out the number of bars that I need. I think it's wasting some time. Yeah, you can see that it has done that already. So now you have 59 white 12 and so on, and let's do that for the other one too. So let's click on it and then let's update. We can now try to see how this works with our model, and as you can see now we have 59 white 12 at 250 spacing to be the top one, and the bottom one is also 59 white 12 at 250 spacing. And as you can see, this is the bar, understand, this is the bar, as much as this is also the bar for the top one, this is the bar for the bottom one. So when you click on this bar, you see that it goes like this, it goes like this. This means that the bar is running from here to here as the bottom one, then there is a return here that is going here to form the top one, you know, and then you have that, and this bar is spanning from here, as you can see, spanning from here to here, and that's the interpretation of that. And the second bar, the bar for the shorter span, you have this to be, the second bar is you have 19 white 12 at bottom one, 19 white 12 at top one. And what this also means is that this bar is, when you click on it, let's go and look for it where it is. So it's here, you can see it here now. So you can see that the bar is spanning from here to here, which means that, and it's spanning from here to here, but it's going to be arranged straight. So it's arranged, as you can see, you have this bottom, this is the bottom one. So the bottom one starts from here, goes all the way here, then it returns and also goes all the way, you know, back down here, see, as you can see. So, and it will be arranged that 1 2 3 4 5 6 7 8 to 19, just like this other one will be arranged, you know, 1 2 3 4 5 6 to 59. So now another thing I would like to touch is the you can see that if you go to the 3D now, you see that it's not a single member, there are different members. There's this slab here, there's this slab here, and there's this landing here, the ramp and the landing. So now, but we designed everything as a single entity. So in case you are detailing this, you have to detail them separately, even though the bars are, you know, arranged already. So in order to detail the ramps, you see that the length of the ramp is can be divided into two, as we have from here to here. So, and since we have 19 white 12 as the bar that is going to be arranged on this entire ramp, you can have 10 on one side and have 9 on the other side, you understand? So you can have 10 on one side and 9 on the other side. You can also have 10 on both sides, depending on, you know, how you want to actually execute your project as a structural engineer. It's actually due to your, based on your discretion, you know, as a structural engineer. Then also for the landing here, you realize that we have 59 going from here to here, you know, for the bars that will be arranging, you know, across like this, that will be arranging on the x-axis, on the x strip. So the y strip was what we discussed earlier, that you can divide into two and arrange, you know, and 10 somewhere, 9 on the other side, or 9 on, or 10 on both sides, depending on what your discretion says. Now for the x strip, we have the landing taking, you know, some portion of the x strip, and which is total 59. So which means to get the ones that is going to come on the landing, you can simply just measure right away from here. This is where the landing stops, to here, and you have 2310, and you can escape that, you can escape measurement. Then you can divide 2310 by the spacing, And as you can see, I have here 2310 divided by 250 gives us 9.24. So which means you have 9 of the white strip coming on top of this, place, and then you can have 9 strips coming, and whatever is left of that is going on top of the rams, at the required 250 spacing. And that's about that, I guess, for this. And the other part that I think you should note is that you remember that we have a wall here, which is on story 1 can be seen, so that we have a wall here. And after we have done our analysis, we still need to check if our design status, if everything that we have done is okay. You can check for your columns here, you can also check for your beams, here. So we don't have beams on story 1, so we have beams and columns on story 2. So these are all our columns and these are all our beams, and you can see that it's ticked green. And in case you have problems, you have some that are actually crossed in red, you could simply just adjust, readjust, or redesign them, not by going to do your analysis again, but you can do that individually. And you can also use your design status. You can go to your review, modern loading review, and your review, you can click on design status to just know the status of all your members. And you can see that these are ticked green, as they are ticked green here, all our beams. And for the columns, you can use your 3D to get the design status for your columns. And once you click on design status, it generates the design status, and you have all our columns also ticked green. So in case you have anyone that is ticked red, you could simply just go and click on it, and then choose section design to design it individually. And if you have many of them having that problem, you could just go back to your structural analysis, and go to building analysis, go to post analysis, then you go to whether it's beam you want to design, and go to column 1 analysis. Then you can double click on each column you want to redesign. And you can also use interactive design. What it does is that it helps you to design automatically and brings out the value, automatically for you. And once you are done, you can press OK. You could also design manually, by adjusting the properties of your rebar, which is quantity, the interior span, the exterior span 2, interior span on x-axis, interior span, or the rear, whatever. You can also the links, you can share design, slenderness, could manually design. And once you manually design, it will let you know whether your supplied is actually equivalent or greater than the required, because if your minimum, if the supply, what you supply is not up to the minimum requirements, then you have a problem. It has to be greater or equal to, just like you see it's designated here. So that's all about for columns. And so you have all the columns here represented, and you can actually just redesign by double clicking or by clicking on it and going to interactive design. Now this is our wall. As you can see, it writes W1 here is our wall, and you know that we are using this wall as a sort of starter bar for our column. And as you can see, it's designated 4 times 1 y12 plus 2 times 12 y12. And what does this mean? You can double click on it to go and check, and you see that this is our 4 y12. You see, that's 4 times 1 y12. Then when you count this 1 2 3 4 5 6 7 8 9 10 11 12, yes, 12 y12. So that's what that represents, and you can see the design right there. And you can also do some other things based on your knowledge of how to use the software. And if it's beam you want to actually amend to, you can do the same thing by double clicking, or you click on it and go to interactive design. I usually love to design most of my beams. I don't use Protastructure default design because it doesn't really feel very much transferable on site. It may require, at some point, it may require some mental gymnastics. So I touched on this. We've touched on this in one of our tutorials on beam design, manual designs of beam, and you can check that out. It's in the link in the description below, so you can check that out. So we prefer to lap, so you just click on it and you lap, and then we remove this support bar at the support. So remove the bar and just lap it. You remove the bar, you lap it, and we don't crank. So, but this is just a personal preference. This doesn't mean that it's the standard. And Protastructure design too is very much okay. It's just that in this client, it's not really very practicable like that. It may tend to waste time, and when there's a better way to arrange your bars, why not just go for it? So you could Once you are finished rearranging your bars manually for the beams, you could just press OK to activate what you have arranged. And if your design was marked red, it's going to be marked green once your design is OK. And that's just about adjusting your column wall and beam reinforcement design. When you have so many of them, they are faulty. But if you have just one or two, you could just go through this route by clicking it and then doing a section design. So I think this is all for it for our tutorial for today. Don't forget to subscribe to our channel for more content like this, and we encourage you to hit your notification bell to be the first to see our latest video tutorials on Protastructure and related subjects on structural engineering, civil engineering, and practical applications of civil engineering. Thanks for watching, and bye for now.